if I can get this pen to work since I don't understand this technology on these Chromebook or these smart boards.
Well, I'm actually excited for the class today.
Why?
I don't know.
I just have a good feeling. I'm glad that you're having a positive attitude towards my class today. You like my presence, you don't like what I teach.
Yo, can we watch Weird Science next week?
Weird Science?
Have you ever seen that? The old 80s movie is hilarious.
Oh, yeah, I've seen it. It's got the kid from The Breakfast Club in it.
Yep.
They make a woman.
Yep.
Weird Science.
It's a good movie. It's not exactly school appropriate, but that doesn't matter.
No, it's not exactly. Anything made in the 80s is probably not school appropriate.
Yep.
I got an 85.
I have no idea how this pen is supposed to work.
It isn't.
No, all right. I'll just go without it.
We make notes.
Yes. Take on something to take notes on. This will be pretty easy today. So this week got changed up from what it was originally because I found out yesterday that we were doing a Monday schedule today, which means we weren't doing a Tuesday, which means half of you don't have class with me on Tuesday because we don't have Tuesday. So if you have me on Wednesday, we're just gonna have a work day. Yes, Abby.
That is not true.
You need a pencil to pry it open?
Like you just need it's physically stuff or it needs an actual zipper part.
I'm a mechanic.
It's stuck in the little.
Did you ask it nicely to open?
All you have to do is I have these ladies.
You have to do this when the kids are great.
No, I have.
I don't know. I've never seen
Respect.
respect.
These books get hold up.
If you can't get it open, I can get you a pencil and some paper.
My computer's in here.
Good. You know, these books get definitely help with you.
It's the second time that I've had it. It's happened over here.
That's it.
I'll get that. All books are like,
Heavy weight.
you touch me, I will really touch you. Take up the chair with me. You touch me.
Why am I grabbing my
I'm so sorry.
It's okay, Logan. You were getting help from Leonard. That was like, all right, so because our schedule is weird, if you have class with me tomorrow, it's just gonna be a work day. So super easy. Thursday, we're gonna have a fun lab. You're gonna get a little bit you're gonna make a little bit of a mess. You're gonna get to play with fire.
Yeah. You get close contact, I'm gonna be very mad.
I am intentionally gonna actually I made this determination. I'm intentionally gonna be staying like away from all of you guys because one, I need to be here, and two, I can't risk not having Christmas with my family because I'm quarantined at stay at home. I'm not doing that. Yes.
Just be cold, you can back.
I've been trying to do that for all of the year.
I got a really powerful.
Hasn't worked out yet. Actually, I kind of think I had it in February of last year, or I was asymptomatic at some point, and
Why is there a statement about Rob?
because Bob Ross is the best.
Oh, I mean, yeah.
It's actually not too bad.
It's not. Why did it
I have no idea. Maybe it's hell right there. Drawing a stick figure with an afro is not super easy.
No, right, here.
Oh, yeah, no. So, next week, on Monday, We're gonna play with glow sticks. Do some stuff with chemistry with glow sticks.
Can I put it in my mouth?
No.
You know how you can actually eat it, you can roll inside yourself.
Yeah, I don't want that to happen.
That's a lot more.
Yeah, we're not doing that. On next Tuesday, I don't know if you've heard, we're doing a shortened schedule. And then the second half of the day, we're doing holiday kind of activities. So next Tuesday, we're not gonna have like a real traditional physical science class. If you have me on Tuesday, we'll probably have like some candy or something, and we'll just watch it.
No, we can go up to your phone.
No,
If you don't care.
but more okay with that.
Forecast baseball.
Hold on. So we do have some notes we gotta take. They're not very hard. I'm gonna try to get this done in 2 mods, so you have that third mod as flex. So do your best to pay attention as much as you can. Ask good questions. If you're confused about something, let me know so I can clarify it so you don't get stuck. If you're at home, if you have a question, shout out so I can try to help as much as I can. Yes. So to start, and this one is just review mainly, so you don't necessarily need to write anything down on this one, unless you just want to make sure that writing it one more time helps you out. Let's do an alarm again.
What? No. I mean, I did, but I still got the score on time.
What did it say on the print?
Covalent bond.
What?
Covalent. Where's my marker? Where's my marker? If you need paper, there is some up on that front table that you can grab.
Yeah, grab me 1, 2, 4. Oh, now you got it. Sounds like you're wearing high heels. Yes,
I am.
It sounds like my mom.
I sound very menacing. It's quite funny because kids always like look behind when they hear me because they sound like a teacher.
When you walk with your heels.
So, all right, I need focus. Focus as much as you can.
I didn't get a piece of paper. I asked for it. Act like I did. No, he got it.
So ionic bonds, hopefully by now, after a week and a half of talking about ionic bonds, you should be able to tell me if I ask you if an ionic bond is between a metal and a non-metal. If not, you can learn that right now. Electrons are stolen from a metal, and that's the basic gist of an ionic bond. Bond between a metal and a non-metal, electrons are stolen, which results in a charge, and you get positives and negatives are attracted because they're opposite charge.
Okay, it's like a dumb question, but still. So technically, wood and metal can stick together.
Wood is neutral charge, metal is neutral charge.
So
Wow.
if you put metal and wood together, technically.
Wood is not magnetic, it does not direct the current, so no, they shouldn't stick together.
So if I were to rub a balloon on metal and
It's the same idea, positive and negative charges in that situation. We'll talk about that later in the year. Don't worry about writing down metallic bond. I just want you to understand it is a third type of bond. You already wrote down, great. This is what happens if you're really wealthy for some reason and you have a ridiculous supply of gold bars sitting in your basement.
I do.
Don't tell anyone because one, that's a federal crime. You can't own gold bars for some reason. Not really for sure why, but you can't own gold bars. I don't know if there's anything in law that says you can't have a gold sphere.
What about a bunch of golden necklaces?
That is completely legal.
So what's the point?
I don't know.
How big is a very, very large pile?
Because gold bars can be used.
Yeah, I think the thing is they don't want any one person to have so much power outside of government. So metallic bonds are bonds between metals and nonmetals where there's more like a sea of electrons. So there's a bunch of electrons, cold, they move back and forth. Again, don't write down metallic bonds. I just want you to know they exist.
I get yelled at for the dumbest thing.
Then you're good, Brooke. So, Cole. So if an ionic bond is a bond between a metal or a nonmetal, and a metallic bond is a bond between a metal and a metal, a covalent bond would be a bond between what? Max? Non-metal and a non-metal. Bond between a non-metal and a non-metal. Yes. Cole, what's up? You're good? Zach, get some notes, please. This would be a good slide to write down. Covalent bonds. A bond between a nonmetal and a nonmetal. With valence electrons are being shared between atoms. This is the type of bond where sharing is caring. Now, when it comes to covalent bonds, they're not as strong as ionic bonds because they don't make charges. But we can share more than a couple types of, why do I have my car keys and all these keys with me? I don't need them. There are some different types of covalent bonds, and I will show you them in a couple slides. But there is some stuff I want to make sure we review before we get there. Covalent bonds, bond between a nonmetal and nonmetal. Valence electrons will be shared. If we look at a periodic table, yeah, it probably is. But, whoa! Not so, yeah, it's fine. This is fine.
Yeah, it's good.
Pre-computer era. They're very low tech.
Pre-computer era.
It's standard.
You know that not right for computers. It's not correct right now because they're cut.
Yeah, it's not completely correct. But for the sake of what I want to talk about quickly, it is anything in green. Anything on green on the periodic table here can form a covalent bond. If you try to tell me anything purple can make a covalent bond, or anything in red can make a covalent bond, you'd be wrong.
Anything in purple and red are wrong.
Blue, purple, whatever. As a side note, if you're, and this is actually genetically proven, girls have more cones in their eyes.
Yeah.
They have better receptors for color. So where a guy sees purple,
I see blue.
girls might see like a really specific shade. I might just be a little colorblind.
We can take a test. It's like 5 tests.
All right. Hold on, Zach. Put your backpack down. Gabe, focus.
You look like a four coming that's not wet.
That was huge.
Drink your water. Don't put it on other people.
Put it on me. It wasn't.
Skylar, what's up? Stretching. Cool. What are valence electrons? Outermost electrons, good. When it comes to any type of bond, ionic, metallic, or covalent, the only ones we care about, the only ones that make any bit of difference are valence electrons. They're the only ones that are going to be shared or taken from an atom. The rest of them don't matter. They're the outermost electrons. We found them on the farthest away from the nucleus. Some atoms have one valence electron, Some have 8.
Am I not?
What's up? Yes. If you don't, yeah, especially if you don't remember what this is, write this down. Hopefully by the end of chemistry, you at least can tell me what valence electrons are.
What if I can tell you everything but a valence electron?
I'd be super thrilled. Super thrilled.
All I know is a valence electron. And it's true. Not as thrilled.
Then I'll be less thrilled, but at least you've learned something.
What if I then you're screwed.
Well,
Can't win.
Drive.
I can try. I can try. I can do everything I possibly can to get you to learn this stuff, and if you don't, I could try a little harder.
They hit them with a hook.
This little GIF here is a nice simulation of what a covalent bond looks like. Huh? Yeah, we're not having that conversation right now. I've had that conversation many times. In this bond, in this covalent bond, people, in this covalent bond, we have 2 hydrogen atoms. Each of them have 1 valence electron. They both want 2.
They steal from the other.
They don't steal, they share with another. They share. I know what you did there. They share with the other. If I were to stop this GIF, whatever you want to call it, I don't care. It's a GIF. Yeah, because it's a GIF. GIF. We need to go back to kindergarten. Probably. That was 1999. We didn't even have, we still had TVs with backs on them. Oh, wow. We still watch VHS tapes back then.
I had the Wonder Baby store episode. It was the best thing ever. Super babies. That's what it was.
This is sad. I have the whole theme song memorized.
Not at all.
Veggie Tales are
Whoa!
Veggie Tales was my childhood.
I'm not that old.
My childhood was Cars, Veggie Tales, and Games.
Pull it back together, guys. Otherwise, we're gonna go into flex time. I don't want to do that. Logan? What?
I didn't hear which people
Veggie Tales.
Okay.
So electrons in a covalent bond are shared. Hydrogen has 1. The other hydrogen has 1. They both want 2, so they share, so they both get 2.
And the second one.
How do we tell the magic number, the number of valence electrons an atom has?
You do math.
You count what? You could do that if you knew how many rings they had, sure. Max? Which column or which group it's in? If I do carbon right now, carbon is in group 14, which means it's in column 14. If I delete the 1, I don't care about it. It doesn't matter. I can circle the second number. Boom! Carbon has 4 valence electrons. I took 14, I deleted the 1, it doesn't matter. Kept the 4, I circle it. That's how many valence electrons carbon has. Yeah. In this case, it does not. If you were asked how many total electrons it had, 14 would be incorrect. All life is based on carbon. And I'll show you why actually a little bit.
What's the scientific solution for that?
Death is genetically programmed into your DNA.
Oh, you can do that.
You could technically, theoretically, you could go in, you could find the gene that codes for your cells to age, you could turn it off, and you could live forever.
But
Wouldn't that stop the age?
Yeah.
And then Earth would-
Living forever is way overrated.
And then if you want to dive into that, or shoot yourself.
Wait, if you like switch it off, does that mean you can't switch
I
it
moved
on?
the game.
Or
You probably could. If you figure out how to switch it on, you can probably figure out how to switch it off.
And if you can't, you can put yourself then, right?
All right. Lewis structures, reviewing from Friday, the simple version of it. Lewis dot diagrams or Lewis structures. The simple way on how we represent how many valence electrons an atom on the periodic table has. We gotta get through this stuff. The magic number when we're doing any Lewis structure is 8, Dave. Magic number is 8. Every atom on the periodic table, minus hydrogen and helium, are trying to get to 8 valence electrons. 8 is stable. 8 is a lucky number. It wants to get to 8. We always add valence electrons clockwise. So as the face of the clock goes, we always add them in, and then we always add 1 valence electron at a time. What I'm saying is like what we worked on Friday, where we had a chemical symbol, like I have the one on the board, the oxygen. I already said carbon has 4 valence electrons. You always start by drawing 1 valence electron on the top. You draw them one at a time, clockwise around your symbol until you get all of your valence electrons. This is the Lewis structure for carbon. It will always be the Lewis structure for carbon.
Why do you need I have to do more than 8.
To move the valence electrons around. Yes, but that is some advanced chemistry that you will not get to in this class, and probably not in actual chemistry here. You would get that at the college level. Yeah, that.
Is there any way to physically change?
Yes. If I put enough energy into that carbon, I could change how many electrons it has. But
But how would you do that?
if you could physically pump up energy in, not just like air, but yeah, like the physical idea of pumping energy in, you could make electrons go. So I want you to take 5 minutes right now. 5 minutes. And do these practice Lewis structures. Carbon, fluorine, radon, nitrogen, phosphorus. Draw on a scratch sheet of paper for me. I'll put the correct ones. I'll come by and check to see that you're getting it. If you have any questions, let me know. There's a periodic table on the back board if you need one. Otherwise, open up your Chromebook and Google search one, and you can pull it up. Periodic table. So the first thing you have to do is you have to figure out what the chemical symbol is for your Lewis structure. The carbon one I already did. I just did it on the board. But the chemical symbol, the shorthand for carbon is the capital letter C. Then you need to figure out how many valence electrons carbon has. Like I had said before, you're going to look at what column it's in. If you look at the periodic table or online, you're going to find it's in group 14, which means it's in column 14. So we're going to count from left to right. You're going to get carbon in 14. You're going to delete the 1. It doesn't matter. Get rid of it, which tells you you have 4 valence electrons. So you're going to take your carbon, your chemical symbol, and around it you're going to draw your valence electrons. We always draw them in 4 spots: the top, the right, the bottom, or the left. Don't draw any electrons here, 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 or here. You only want them on the 4 sides: top, right, bottom, or left. You can only fit 2 valence electrons in a spot. So say I didn't have 4 valence electrons, say you had 5. I would add my 5th one on the very top. If I had 6, I would keep going around the ring until I got to 8. We don't go any larger than 8, but you can be less than 8. Okay? All right, I'll come check in a second.
15.
My legs are sore.
I like to buy it.
You need to do every single one of them?
Yes, you gotta have the chemical sample. We are going to action a slide or two. I'm gonna show you how to do it.
Mr. Wells,
Yes,
I have a question.
speak.
Who is that?
Go ahead.
So are we just doing what we did last week?
We are reviewing it right now, but yes, on this slide, we are doing what we did last Friday. And then in a couple slides, we're gonna put the next step in.
Okay. Okay, that's my question. Bye.
Yes, 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 yes. Yes, 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 yes. Yep. Actually, nitrogen is not right. Phosphorus is though. The rest of them are good.
I love that dude.
Mr. Wells, you know what I did this weekend?
I went to a Covalent Facebook page and I asked them.
Yep.
I did that too.
Yep.
They don't respond.
Yep.
I'm really good.
It's okay, I'll fix it.
Yeah, I don't know.
I'll fix it then.
My butt itches now. Oh, why you didn't
Yeah, I'll go through.
Wow.
Yes.
Are they supposed to find all of them?
Yes. Yes. Good man. Plastic water bottle.
I gotta look at a picture of it.
No, you don't.
Yeah, I do. Like, you gotta
Don't
get
get yourself that way. Just walking around, shoot. Yeah. Looks like there's lots of
It's loading well, it's okay. I got it.
You give monkey mercy. Nope. Mr. Wells versus yes. Whoa! No, there should be one in the room over there. Yes.
Nice and cold for that. Is that a pen?
Copper wire. You can have, you can do whatever you want with it. It was on the floor. Yes, yeah, logically. Yep. That's why I put them up there. All right, it looks like everyone's got kind of the graph. If not, I was not able to check it. Here are the samples. The only thing that changes, that might throw you off, is nitrogen and phosphorus. These two pairs, or this one pair, should be on the top, and same with nitrogen. Otherwise, it's the same. Nitrogen and phosphorus have the same number of valence electrons because they're in the same group. So if you ever come across one atom or element that has the same number of valence electrons as another, that is because they are in the same group. So don't freak out. That's fine. It's okay to have the same number of valence electrons as another. So, Brooke, and this is probably a good question for you because you ask me all the time. And I think you asked me this on Friday. Why?
Do you like his job?
Why do you know?
I did a new job.
No, not that one. Usually it's why, what am I gonna need this for?
Yes.
So on Friday, I had you make these Lewis structures. We're already going longer than I wanted to. On Friday, I had you make Lewis structures. If you don't know what they're for, you're probably asking yourself, why am I doing this? What is the point of drawing 8 dots around a chemical symbol? What good is it to me? And the reason is, well, that is very important, especially if you want to do biology, you need to do this. With this particular thing, it tells us how many bonds, how many types of covalent bonds that atom can make. And it shows us, like a puzzle, how we can fit them together. So here I have 2 Lewis structures, one for fluorine, one for hydrogen. If I wanted to form a covalent bond between fluorine and hydrogen, where would this hydrogen fit? Ellie, where? Right in this open spot. We want to fill this spot. We need to fill it. Fluorine is not happy. Yes, I can erase it. It's fine. It's basically a whiteboard with a projector. It's not that. It's not a normal smartboard.
That doesn't look right.
I can clean it off.
Did you guys pull up on here?
Yeah. I should do that. Shish. So, quiet. Guys, quiet. So we have an open spot here. Hydrogen has 1 valence electron, fluorine needs 1. We're gonna slap it into that spot, and boom, we have a covalent bond. If I circle hydrogen is weird. Out of all of the atoms in the periodic table, hydrogen is happy with 2 valence electrons. Does hydrogen have 2 right now? Yes. It's sharing them with fluorine, but it has 2. If I look at fluorine, how many does fluorine have?
8.
How many does it need? 8. Is this stable?
No.
Yes. Hydrogen only needs 2. Hydrogen is weird. It only needs 2. Fluorine needs 8. It has those electrons. It is stable. It is good. It is not going to explode. In fact, that actually makes an acid that's super toxic. They're super hazardous. What about this one? How would I bond this together? Mo, what's up?
I have a question. What was the other element that you said with didn't need?
Ow!
Helium doesn't. Yeah, Brooke.
Combine the 2 hydrogens, so like there's one side and one on the top, and then you just sit it on.
So like this?
Oh shoot.
That one. There we go. What Brooke just said, up on the board. Well, we just went forward. Yeah, Zach.
So, technically, the letter has nothing to do with anything.
The letter tells you or identifies what atom you're talking about.
So it's literally,
It's just to label it. That's the only reason we have the symbol there.
Okay, I understand that.
So hydrogen, if we had 2 hydrogens and an oxygen, oxygen has 6 valence electrons. Hydrogen each has 1. They both, or oxygen wants 8. If I circle it, oxygen has 8. If I circle hydrogen, each of them, they both want 2. If I look at both of those circles there, hydrogen has 2 for both, oxygen has 8, ion stable. That is a good way to draw the covalent structure for water. H2O. Oops. Now, and I'm gonna keep moving because we're taking too long. Oxygen and oxygen. This can form a bond. They both have two empty spaces, so we can fill that and we can bond them together. So if I were to draw a circle around it, not a circle, whatever shape this is, Pac-Man. This is Pac-Man. If I draw this same thing here,
What is this, a maze?
no. So if I look at this oxygen here, 2, 4, 6, 8, 8, 2, 4, 6, 8.
2, 4, 6, 8.
This is the oxygen we breathe. O2.
Is it O2 because there's 2 zeros?
There's 2 oxygens, two O's.
I knew it.
O2. What time do we get with this? How much time do I have?
They're growing. I think it was.
Yeah,
Okay, so if you take water, H2O, got one hydrogen atom, what would it become?
what we call it is hydroxide, it would be HO. It's also, if you put it on like, bond with a bunch of carbons, it's what you get alcohol out of. Rubbing alcohol, the more interesting kind that everyone talks about for some reason. Whole bunch, any type of chemical alcohol. OH.
Okay. Mr. Wells, what element, whatever has, like, whatever it's called, TN?
Technetium? I think it's technetium.
This is how monkey.
Helium.
No.
Hold each other's hands.
How about the
2 slides left, and then we're done, and you can get out of here. Two slides left, and then you're done, and you can get out of here. So when we're making, or when I give you a picture of a bond, so on Friday, you're going to have another learning check like we did last week, same setup, formative, super easy. I might give you this picture. I might give you this one. I might give you this one. What I want you to tell me is how many covalent bonds is it making? So what type of covalent bond do we have? So if I draw one line, that represents a single bond. So one straight line, one dash represents a single bond, and that represents 2 valence electrons. If I have 2 lines side by side in a drawing that looks like this, that represents a double bond, and there's 4 valence electrons in that. Every time we add a bar, we add 2 valence electrons. I can make up to a triple bond. I can't go any higher. A triple bond shares 6 valence electrons between the 2 atoms. Zach? You can't bond, one atom can only have 1 triple bond. It can't make 2.
So you're talking more technically 2 atoms into substance. What I'm trying to say is, can they connect?
You can connect with a triple bond. So, to determine how many bonds an atom can make, we will look at carbon, because carbon can make the most. This is the Lewis structure for carbon. We've drawn it a couple times now.
Why are you drawing it, Connor?
Yeah, I'm a monster. I know what it is. I got it memorized. How many valence electrons does carbon need to be stable? 4. It needs 4 more. How many bonds can carbon make then?
4.
It can make up to 4 bonds.
Oh, thank you. It's Keaton.
If I draw nitrogen, and yes, I'm going to draw, this is nitrogen. How many electrons does nitrogen need to get to 8? It needs 3 more.
3.
It needs 3 more. How many bonds can it make?
No. So however many it needs is how many bonds you make?
How many bonds we can make? We can make up to 3 bonds, okay? If I look at carbon, I can make a triple bond with carbon. So say I share 6 electrons, I can do this. So let's say there's another carbon over here. I can triple bond, so there's 6 valence electrons here that are being shared between the carbons. Carbon can still make one more single bond over here. Okay? So maybe I have hydrogen here. I know. I was just trying to answer a question. That's more advanced than you're gonna have to know.
Oh, I understand.
Do you do it? I don't know.
Carbon can only make 4 bonds. Yes. It can only, so it can only make a triple bond with 1 atom. So here, there's a triple bond. I can't come on this side of carbon and make another triple bond. There's not enough electrons for that. No. There's an argument that you can do sulfur. Sulfur and phosphorus could do it, but no.
Would you do a double bond then?
But yes, so you can do this. 4 bonds. 1, 2, 1, 2, 4. I just can't do this. 1, 2, 3, 4, 5. That's too many. Carbon can only make 4 bonds. 1, 2, 3, 4. That's chemistry level stuff, though.
We did a lot of chemistry level stuff today.
Yeah, we have. How many valence electrons in a single bond?
1.
Max?
Oh, it's 2.
2. 2.
Because it's 2 bonds for me.
How many double bonds?
4.
4. How many triple bonds? Thank you. What is a covalent bond? Bond between the nonmetal and the nonmetal that does what, Cole? Share electrons. What kind of bond is this? Single bond. What kind of bond is this? How many is this? If you don't have any missing work for me, you can go. Stop it. What's your question, Abby?
Bye, Wells.
Bye.
Thank you. Have a nice day.
Bye, Wells.
Yeah, potatoes. So you can take potassium, but potassium is a metal. Potassium is a metal.
Okay, yep, too much like.
What's up?